Today, a bunch of monkeys process items and throw them to other monkeys. For example, monkey number 0 has these items to process. 79 times 19 is a bigger number. Then the monkey checks, is the new result divisible by 23? If so, he passes on the new result to monkey 2, otherwise to monkey 3. Then 98 is processed, then monkey 0 is done, and monkey 1 continues. And after every monkey has done this, then 1 round is done, and we want to perform 20 rounds. Okay, so since we're doing a lot of mutation here, passing items into other lists, I decided to convert the persistent monkey into a mutable monkey by turning the vector into an array list and adding a volatile counter. So that would look like this. The items is now an array list, visually indistinguishable from a vector here. And the counter is a volatile with a value 0. Volatiles are Clojure's most lightweight identities. Then we have a divisible helper function, just because this idiom is not as readable as divisible. Then for part 1, what do we do here? So we want to do 20 rounds. Here the persistent monkeys are mapped into mutable monkeys, and then we iterate for every monkey in those monkeys, and the monkey is destructured into the keys items counter operation denominator. So the local binding items would be colon items of the monkey, the local binding counter would be colon counter of the monkey, and so on. And here we add the count of the items to the counter. That's simply what we have to do according to the spec. And then we loop through for every item in the items, we perform the operation. And then we perform an integer division by 3, rounding down to the nearest integer. And then we check, is our new item value divisible by the denominator? That will be either true or false. And we use that Boolean value as a lookup into our monkey object. So either it will be true, then we get the true value, or it will be false, then we get the corresponding false value. Okay, so this number, this index, we use to index into our monkey's vector. Then we have the target monkey. We ask it for its items array list, and then we add into that array list the new item. And finally, we clear our items because they were successfully processed. Right, and once we're done doing that 20 times, then we start with our monkeys and map the counter keyword over that. Then we get all the counters as they are after processing. Let me format that here a bit like this. Here you can see the 4 volatiles, and we're really only interested in the 4 values, right? 101 at the front, 105 at the back. So we also want to deref the volatiles. That's how you get at the internal value. And here we go, 101 at the front, 105 at the back. Then we want to sort those values, then 105 and 101 are at the front, and then we want to multiply the first 2 values according to the spec, and then the tests pass. So that was relatively straightforward. Right, and then for part 2, the problem is that these operations, plus, times, squaring, make the number quite big after a couple of rounds. So in part 1 we only have 20 rounds, but in part 2 we will have 10,000, and those numbers will simply become too big. Okay, but there's a simple trick. So after each operation, we're really only interested, is it divisible by 13 or 17 or 19 or 23? Those are the denominators in the example. And if that's everything we care about, we don't have to have the result grow bigger and bigger and bigger. We can, every time after an operation, mod by the product of all the denominators, and that won't change the result with respect to mod 13, 17, 19, or 23. That takes some thinking and being familiar with modular arithmetic, of course. Okay, so let's look at the code. So here we have 10,000 rounds as opposed to 20. And here I calculate what is actually 13 times 17 times 19 times 23. That's this guy here. That happens to be 96,500. So every time the result reaches this value, we can wrap back around to 0 basically. And not change the mod tests for divisibility. Okay, so what else is different? Here, instead of dividing by 3, now we calculate the remainder with respect to the shared denominator, and the rest is basically exactly the same. Yeah. And what I did wrong initially is to use the wrong denominator here. So instead of using the product of all the denominators, I simply used the current denominator. And then you get a slightly different value. In case you get this value, you know, oh, whoops, I used the wrong denominator. So let's undo that and use the correct denominator. Then you should get the correct result.